let us have a look at this. So ये spectrometer है, it is a sodium light, it is inside a wooden box, और यहाँ पे एक फाइन स्लिट है, फाइन स्लिट से लाइट निकल रही है, एंड दिस इज कॉलीमेटर एंड दिस इज टेलीस्कोप. सो कॉलीमेटर क्या करता है, what a collimator will do, let us have a look at it. So let me go back. Yeah, so there's what is collimator will do. Basically, so light is coming from this point, this is a source of light or the slit, or say light is coming from source of light and it is a slit, light is passed through this, and there is a lens, and what this lens will do, say it is a convex lens is here. So when light is coming from this point, and this, if this distance is at the focus equal to focal length, then light comes parallel, and when light comes parallel, this light is observed with the help of a telescope. This is the combined diagram of this one. This is collimator and this is a telescope. Why we are using telescope? Because the rays are coming parallel, so therefore we are using a telescope here. So let me go to the next page. Yeah, so this is the diagram, and here in this particular diagram, light is coming from here, and this is a collimator, this is a telescope, and here in the spectrometer there are two Verniers scales, one is here and one is here. So when this telescope is rotated in this way, then what we are getting, we can measure the angle, and this is a prism, and this surface is opaque, and this face and these two faces are basically refracting faces. So here the light is coming parallel, made to fall on this one, and it is reflected like this. Light is coming this side and it is reflected like this. So we have to measure this angle between these two radiations, and this angle is theta, and angle of prism is nothing but it is the theta by 2. So let us have a look at a small video is there with us. So it is a prism. Say initially light is coming, say a parallel ray of light is coming from this, it is made to fall at this point, and after this light gets reflected in this way. Just a minute. So this is the reflected ray of light. So what we will do, we will bring this telescope here and we will try to see this radiation, and then we will note down the reading of this Vernier V1 for phase 1. So let us call it as a first phase, and this is the second phase. So we have to measure this angle theta. So that means what we will do, for the Vernier V1 we will take a reading for the phase 1, and similarly phase 2, when the telescope, first of all we brought telescope here, and after that we will take this reading, and similarly we can also take reading of the phase 2 for Vernier V2 from here. This is V1 and this is V2. So we will take reading for the phase, sorry, it is the first phase, right? It is not a second phase, because I am looking at this phase from telescope is at this position. So when telescope at the phase 1 position, we will take the reading of Vernier V1 for phase 1, and similarly we will take Vernier V2 reading for the phase 1. Then we will rotate it back from here to here. Now we are looking at the second phase with the help of a telescope. Now we have to take the reading of Vernier V1 again. So, and similarly we will again take the Vernier of V2 reading for phase 2, like this. So that means this reading of B1 for phase 1 and phase 2 is the measurement of angle theta. The difference of these two values is basically theta. Similarly, the difference of these two values is also theta. Then we can measure angle A, basically theta by 2. So what we will do, we will take the average of these two values, theta for B1 and theta for B2, and the theta is basically, the theta angle is basically theta V1 plus theta V2, their sum, and then divided by 2. It is the average of these two values. That's what we will do here. So let us have a look at this particular video. Say this is Vernier B1 and it is a collimator. Let me briefly talk about this collimator also. In collimator, this is basically rack and pinion arrangement. With the help of rotating this, I can increase or decrease the length of this tube so that a fine slit is visible to us, and with the help of this screw we can adjust the width of slit, and this is to fine tune focal length so that parallel beam is formed, and this arrangement is known as rack and pinion arrangement, right? And after this, see how the focal length is changed. So we can vary the focal length. And see, now I brought a telescope here in this position and try to see the slit. See, so light is coming from here and it is made to fall here, and this is the slit was visible through this. This is the eyepiece, like this. And now I go back to the second phase. So similarly, I try to see light is made to here fall here, and here it is adjusted like this. So I have to measure, because I rotated telescope from this position to this position. So that means this angle is theta. So this is Vernier B1 and this is Vernier B2. I have taken the screenshot of these also. So I will tell you that what is the reading of this. And also let me, so if I have a look at this, it is a collimator. Here are the two screws are adjusting screws are there. With the help of these screws we can align this collimator straight, and similarly two types of screws are also there, adjusting screws. With the help of this we can align this collimator and telescope in a straight line so that light will come horizontally. And after this, what do we do? These are the leveling screws. Sometimes what will happen, slit from one face is little bit aligned up, and for the second face it is aligned down. So we have to bring that slit into the center. Also we can make adjustments, small adjustment from here, so that first of all we have to level this spectrometer. Then this is the prism table. Means there are few steps which we have to follow. First step is align this, what we call we have to align the collimator. and telescope with the help of these screws. And another step is we have to level this spectrometer. Then third one is level this prism table. These are the few steps which we have to follow, and if we follow these steps, then the slits from the both sides are aligned properly and we can see those visible. And ensure that while we are rotating this telescope from one face to the another face, this spectrometer should be intact. It should not move, right? These are the few steps which we have to follow. So now let us take the readings. So here I talked about this also. Then yeah, so this is the phase 1, and when telescope is in the phase 1 position, then this is the slit. I have taken the photograph for this, and here it is a crosswire. It should be aligned. See, this is aligned properly. So that means we have to adjust in such a manner so that crosswire is in the middle of this slit, and slit should be fine. So slit is visible to me here, and this is the reading of V1. And what is this reading? Let us have a look at this reading, that what is its value. So see, it is 120, say it is 120 and it is 119. So before the zero of this, the reading is 119 degree. And now which one is the most coinciding division? Means this is the reading of main scale. It is main scale reading. Now we have to multiply least count. Least count is 1 minute, and the most coinciding division is what? See, let us have a look at it. Which one is the most coinciding division? Yeah, this is the most coinciding division of this division. So it is, which one division is this? Say 5, 10, 15th division is the most coinciding division. So 15th division is coinciding. So reading is 109 degree 15 minutes. So this is the reading. Clear? So for V1, let me do for the phase 1. Let me go to the next. So for means what we will do for the phase 1 and for phase 2, similarly these are the readings of vernier V1. These are the readings of vernier V1. Similarly for phase 1 and phase 2, we have to take readings of vernier B2. So for this, what is the value? The value is 119 degree plus 1 minute into 15th division is the most coinciding division. So what it will be, 119 degree 15 minute is the reading of this one. So now again go back. For the phase 1 is this value, and then for the phase 2, what is the value? Say it is 240 is here, and both are exactly coinciding. If I draw a line, it's a slight line, if I draw, then both the lines are exactly coinciding. So that means 240 degree is the value of this one. So what is it? It is 240 degree. It is 240 degrees, the most coinciding value. So the difference of these two values is theta. Let us do one thing. Let us talk about that later on. Or I can also do one thing. I can also estimate theta from here also. So this is the for first phase, this is for second phase, and let us have a look at. So here it is theta. Theta is basically the difference of phase 1 and phase 2, the difference of these two values. V1, so sorry, the difference of these two values. So let us do a small calculation here. It is 240 degree 00 minute. So it can also be written like this. It 290 degree this value and 60 minute, and here it is 119 degree and it is 15 minutes. Minutes can be subtracted from minutes. So here it is 45 minutes, and what it will be? It is 120. It's a 120 degrees. So this is the difference of these two values, right? Let us go to the now next part. What was that? Oh, sorry. Yeah. Similarly, I have taken readings of V2 and V2 for the phase 1 and a phase 2. So what is it? What is its value? So if I look at this carefully, yeah, so these both are also coinciding. These both are also coinciding here. So what is it? So it is 300. That's a before 300. So it is a 300 here. So it is 300. Sorry, not 300. It is 299 degree. So it is 299 degree values, this one. So let me go to the next page. So it is 299. So the value is 299 degree, and let me again go back. Yeah, let us try to look at this value, and this is little bit smaller. So this is here, so it is 60. This is basically 60. So before 60, this value is, yeah, say it is 59. So it is before 0, it is the between these two. So it is 59.5 degree. It is 59 degree, yeah, or we can call it as 59.5 degree. We can call it as 59 degree 30 minute. And let us go to the most coinciding value. So which one is the most coinciding value? It is which one division is the most coinciding? This division is most coinciding. This division is most coinciding. So it is this is 30th division. So before this it is the 1 2 3 4. So it is 25 26 27th division is the most coinciding division. So it is 27th division is the most coinciding division. So plus least count 1 minute into 27, so its value will be 59 degree 57 minute. So what is it? Let me go to 50. Yeah, it is this one. So let me 59 degree 57 seconds. So it is this value. Now if I take a difference of this two, then this difference is round over 240 degree, but there is a lot of difference between this and this. So it is because of the reason that say when vernier V2 is showing, say if I look at the reading when I am moving from phase 1 to phase 2 for vernier B2, then what I am saying that, say the divisions are like this. Say 299 is here, where roughly I can call it as it is near the 300 degree, then it is 310, 320, 330, then 340, 350, 360, 370, but it is not 370. It means it is a 0, 360. Then after that it is 10 degree, it is 20 degree, it is 30, and then 40, 50 and 60 and so on. It is 50 and 60, 40, 50 and 60. So it is going like this. So that means we have crossed, when I am moving from phase 1 to phase 2 for vernier B2, I am moving from 300 to 360 and so on up to, and then again coming out to be this one. So what should I do? I have to add 360 to this one. I have to add 360 to this one. So when I add 360 to this one, then what I am getting, it is 57 minute, and it is 9, and it is 5 or 6 is 11, yeah, 419. It is 419 degree and the 57 minutes. That's what we are getting here. So that means for this, how we can calculate, it means we have to ensure that how the values are moving. We have to see the pattern, that how things are changing on the scale, whether 360 is crossed during my measurement or not. When 360 is crossed, that means I have to add the 360 to that particular value, and then I can estimate the actual angle. So that means the theta is basically from here. What is theta? From here I can calculate theta, and theta is basically here 419 degree 57 minute and 299 degree, right? So it is 57 minute, and here it is 400, and so it is a 120 is the difference between these two values. So it is this one, 120 degree. So that means we have to see this very carefully, otherwise we will stuck somewhere. So that means, so theta for V1 is basically 120 degree 45 minute, and the theta for second vernier is equal to 120 degree 57 minutes. So what is theta? Theta is the average of these two. It is the average of these two. So how average is calculated? 120 45 and 120 57. Let us take a sum of these two. So what it will be? It is 2, 4 and the 5 is 9. So it is a 1 0, just 4 5 and that, yeah, it is 102 minute, and here it is 240 degree. So that means average is basically, so theta is equal to theta V1 plus theta V2 divided by 2. So it is 240 degree 102 minutes whole divided by 2. So here it is 120 degree and here it is 51 minute. That's what we are getting here. This is theta. So now we can calculate the value of what we can calculate value of angle of prism. Angle of prism is equal to theta by 2, so 120 degree and 51 minute, it is divided by 2, so it is 60 degree and 25 minute, and 1 minute is also there, so 1 minute divided by 2, so it is 60 degree, 25 minute and 30 seconds. So this is the value of angle of prism. So thus we can calculate the angle of prism and comes out to be nearly equal to 60 degree and 25 minutes. So that's all for this lecture. And in the earlier lecture I also told you that how angle A or the angle of prism is comes out to be a theta by 2. Let me briefly go back to here. What is angle of prism? From this diagram, say here this is the face, one face, and this is the other face. The angle between these two faces is basically angle of prism, and theta is basically this angle. This angle is this theta, and this angle is A. So that's all for this video.